Hello everyone, welcome to the part 5 of the Assembly Language Primer for Hacker video series. In this specific video, we will look at how to go about defining various data types in assembly language. Now if you remember, in the previous video we had talked about the .data and .bss segment in which variables can be actually stored. So we'll first look at the .data segment and see the various data types which can be used within this segment. So the first is .byte, which is actually 1 byte. Then we have .ascii, which if you remember in the previous video is basically a string. Then we have ASCII, which is nothing but the null terminated string. Then .int, which is a 32-bit integer, .short is a 16-bit integer, .float is single precision, and .double is double precision floating point numbers. Now many of these different data types are almost exactly as in the C language. The important thing to note is that the space for these data types when they are defined is actually reserved at compile time itself. So we'll get into a small demo of how to go about exploring these various variables created using these data types in an assembly language. So before that, let's quickly look at the various data types which can be defined in the .bss segment. So we can define the .com, which is COMM, and this declares a common memory area. And there is a variation of that called .lcom, which declares local common memory area. Now I will not get into the exact details and differences between both of these for now, just to keep it simple. However, the important thing to remember is that anything declared in the .bss segment is created at runtime. What this means is whatever you define here is not going to occupy any space inside the executable which will be created using the assembler and linker. Only when it is actually loaded into memory as a program will the space actually be created. So with this very quick 2-slide presentation, now I'd like to go into a demo of exactly how these variables, these data types can be used to define different variables in an assembly language program. So I've actually written a very simple assembly language program called variable demo. And what I've done is quickly gone ahead and defined various variables using these data types. Now the way we do it is by defining labels and then using the specific data type. So this is a very simple program. First we define the .data segment. Then we go ahead and define the BSS segment, and then finally the executable code, and we have the start function, right? And here what we've done is it's a very simple program which just exits for the time being. However, what we are really interested in is not in the execution of the program, but exactly how all this data is going to be stored in the program. So we've defined an ASCII string called hello world. We've defined a byte location which contains the value 10. We've defined a 32-bit integer containing the value 2. And we've defined a 16-bit integer containing the value 3. So the way all these definitions run along is basically you give a label which is something like the variable name, and after that you go ahead and mention the data type and then finally the value. So hello world is the label, .ascii is actually the data type, and then this is the actual value which is hello world. Similarly, we've defined two other labels, float and finally an integer array. So if you notice, what we've done is in the case of an integer array, even though it is of type .int, we can go ahead, give a comma separated list of integers which will be stored one after the other. Then finally, in the BSS segment, we've defined a large buffer of approximately 10,000 bytes. So now let's quickly go ahead, compile this program. Let's assemble it, giving a hyphen. And then we go ahead and link it to create the executable. Now once this is done, let's execute the program. So it just exits, nothing much to see here, but let's load it up in GDB. So in the previous, I think in the third video, we looked at how to use GDB in order to look into various aspects of a program. So we can just hit on list and the whole program gets listed. What we really want is to go ahead and set a breakpoint where we can go ahead and observe what is happening in the memory. So let's create a breakpoint. And let's go ahead and run the program. So if you notice, we hit the breakpoint and this is where we are. However, at this point, this is not really relevant. What we are interested in is to look at the variables which we created using these data types. So let's actually open up another terminal where we can simultaneously look at the program. So how do we look at all these variables inside GDB? So very simply, you can just use info variables and we go ahead and get a list of all these variables, right? So this is the memory location and this is where, this is the label of that memory location which we've given in our code. Now, how to go about looking what is available here, right? Or basically, how to find the value of hello world. So if you remember in video 3 in the GDB basics, we had looked at the examine memory command, right? So this is what we are going to use here, where we know that hello world is nothing but a string which is of 12 characters, right? So we use the examine memory command. The next thing we need to give is the number of the number of specified objects, and then basically what we need to give is actually the format in which you would like to go ahead and do the printing. So let's say in this case it's going to be a character, and then finally what we need is the size letter, which in this case is going to be a byte, and then we go ahead and give the memory location. So if you notice now, we have the whole hello world string in this memory location. Hello, this is the space in between, then we have the world, and then finally the exclamation mark. So similarly, let's say if you wanted to look at the byte location, we just need to use the examine memory command, say just one of the specified objects. We want it to be displayed in decimal, and the size is 1 byte. And at this location, we have the value 10. If you notice, this is exactly what we had defined using the byte location label. So similarly, let's say if you want to look at int 32, it's very simple. We want to print that in decimal. However, we want a word to be considered as the size of the variable. So let's go ahead, give the memory address. And if you notice, we have the value 2 here, which was exactly what we had defined here. Similarly, if you wanted to look at the 16-bit integer, we need to go ahead and give a value of half word. And then we go ahead and give the memory location. So we have the int 16 here. This was exactly what we declared. And now we can look at the float. See, the reason why I'm going through such an elaborate and detailed example is that it is going to be very important that you know how to go ahead and seed through memory to find out how variables and many other things are going to be laid out in future programs which you will create. So it is very important that you get an absolute hold on how you can go about doing these things in a very fast way. So now we need to display this in the form of a float. And what we really want is basically to give the memory address at this point. And if you notice, we have the value 10.22, 4 9s and 5. However, here we have 10.23. So I leave this as an exercise to the user to understand why this is not 10.23 and has been written in this way. So it's very simple. Think about what a float is and the way it is represented. Okay, then finally what we have here is an integer array, right? So how to go about looking at this entire array? So once again, the examine memory comes to our help, where what we really want is to go ahead and display all of these integers. These are 5 integers. And then to go ahead display them in decimal, and the size is going to be a word. So now if you notice, we've printed the entire array 10, 20, 30, 40 and 50. Finally, what we want to look at in memory is the large buffer which we've assigned, and this is also pretty simple. Let's say we just want to look at the first 10 memory locations, throw it out as a decimal value, and then go byte by byte. If you notice, we have nothing but all zeros here. And we could actually even look at a large section. Everything is just going to be zeros. So well, that's all for this demo. Very simple. Download the code, assemble it, link it, and then go ahead and try this out yourself. It is very important that you understand how these variables are being laid out in memory and how to go and look at them if required. In the next video, we will go ahead and see how to use the different kinds of move instructions in order to move data around using the CPU and memory. Well, that's all. I would really appreciate if you can leave a comment behind if you liked this video, or if you hated it, or if you have any other comment. Please leave that in the comment section below. Thank you.